Okay, let's see how this one goes. So, the problem proposed to you, the first one yesterday, was tennis, anyone? I have 3 of these tennis balls with a radius of 2. That sounds about right. 2 inches, by the way, I guess. All right? And the answers, at least on the test, were supposed to be in terms of pi, but we could get our final answer and just multiply it by pi and round to 100th or 1,000th or whatever they want. So it really wouldn't make a big difference. And I'm putting all 3 of these guys, when I buy it, right, all 3 of these guys are placed inside here. Maybe if I were better at art, this would be a little longer, right? Not that it makes such a big difference. So now the task is to figure out, number 1, what's the space left over in terms of pi, which again, since they talk about inches, could easily be turned into cubic inches. In fact, I can do that if you like. And the second question is what percent of the container is empty, or its complement, which would just mean full. So either way, whichever way I do it, one complements the other, so you'll know. So let's try it right now. And we start with the overall configuration of what's going on. So it's pi r squared h, the container, minus, of course, the 3 balls. So let's slow down here just a little. 3 of them, and each one has a volume of 4 over 3 pi r cubed. And you should be able to do this in 8th grade. Okay? That's the setup. That's how it works. That's what makes the problem so easy. We mentioned the word snug before, that they fit snugly inside. That might mean if you rattle or shake the container, it won't make any sound. You won't hear anything rumbling around inside. And now I plug in the data, and I get pi 2 squared times 12 minus, I'm canceling here, okay, 4 pi 2 cubed. Okay, so there we go. Once you did the hard part, setting this thing up, you're in great shape. This is 4 times 12, so this is 48 pi minus 8 times 4, 32 pi, and the answer would be 16 pi inches cubed. Okay? All right, you're a scientist, you say, I don't like that. Okay, so we'll just put it on the calculator real quick, and it's 16 times the pi button, if you like, and the answer would be 50.265 inches cubed. Again, we round since we talked to the 100th. I'm still good on the screen. 0.27 inches cubed. Okay, so it's answered 2 ways. Notice we didn't have to use a calculator unless we were really concerned about what the empty space is. The second part of the problem's even easier. We'll set up a ratio, empty. Okay. Actually, a better way to do it, let's just not confuse anybody, is the space occupied by the tennis balls divided by the container. That's probably the best way to look at it. There are other ways actually to do that, but that seems the best way to imagine this problem. But then it's automatic. We've been doing this all along. The tennis balls, as you can see from the problem here, they occupy 32 pi inches cubed. The container, which we calculated over here, is 48 inches cubed, okay, pi. Pi's cancel. 8 divides into this. Let's see. 8 with. Let's see what goes on here. Let's see. 8 goes 4 times, 6 times. So this would be 16 would be the, so it would be 2/3 occupied. And believe it or not, that's what we came up with before, or when we round 60%, 67% occupied, 33% unoccupied would be the correct answer. And then again, you see how the Common Core has set you up so that if you've done the problems that I've done with you before, a problem like this, once you got the initial setup, multiplying it by 3 turns out to be an easy problem, even though it looks so formidable when you first look at it. Okay, second problem. Let's see. Not bad. Okay, so second problem. And this problem's a little tougher. Nobody would deny that. I'll remind you of similarity. Okay, we did do similarity. If I had 2 right triangles, one big guy, and I say he's similar to the little guy, and remember, you're responsible for knowing your math, okay? You're responsible for knowing these things. You can't just say, I totally forgot. And let's just say that this side is 12, and this side is 4. So that's, and this side is x, and this side is say 3, just to make the math easy. Then we say 12 is to 3 as 4 is to x, but you don't even have to do that. You can cross multiply and clearly see that x equals 1. So I'm going to use that trick with similarity. All right triangles, not all right triangles, but right triangles with proportional sides are always going to be similar. Okay? Remember what I said before, all spheres, all squares, they're always going to be similar because they only differ by the radius or a side. So with that in mind, I'm going to do this problem. That was the key insight into the problem. And here we go. Here we go. We got a big guy here. And we cut it halfway. But human intuition tells you that the volume of this top guy is not going to be the same as the volume of the bottom guy. That should be pretty obvious to everyone. And again, we can work in inches or units. It's not going to make such a big deal. And then we need, of course, let's see what I gave you. Did I give you the diameter? Yeah, I gave you the diameter as 8. All right? So the question number 1 was, what's the ratio of the, what's the volume of the stump? That part that was left over, we can draw that right now. Okay? All right? And then what is the ratio of the small cone to the large cone? So I'll do them in order, and let's see how that works. So the large cone, okay, take away the small cone, gives you the stump. And you should think about that if you didn't see it, okay? You should definitely think about that if you didn't see it. It seems pretty obvious to some people, but maybe other kids are a little stumped by that. But I'm just subtracting the big guy and I'm subtracting this part, which I chose to cut off halfway. That's going to help us when we do the work. So the real question is, r equals 4, right? Get rid of that part right there. So r equals 4, and the height equals 10. So I'm easily able to calculate the volume of the first guy. So I go 1/3 pi 4 squared times 10. And then I minus the smaller guy, which is 1/3 pi. I have to stop here, guys. And I'm doing this deliberately anyway. What is r here? Well, I just explained it to you, but I'll explain it again. We have two right triangles here. Let me get out of the way. We got a right triangle here. We have a right triangle here. I'll do it down here. So that means we have a big right triangle. And R is 4. It's a right triangle because it's a perpendicular bisector here. And the big guy is 10. And it has to be similar to the triangle. They're the same triangle. It's just cut so that it's deliberately similar to the small guy. And its height is 5. That's data given to you. So what is R? Well, 5 is to 10 as 4 is to what? 2. And if you need to do a proportion to see that, good luck. I don't really think you need it. So there we go. That was the problem. That was all you had to really see to make this problem work. And then that's 2 squared times 5. So there's your radius here, there's your radius there, and we're able to easily do the problem now. No need to cancel. We couldn't even if we wanted to. 3 and 2 and 5 and 2, they're all coprime numbers. So we'll just work this way down here. So I'll keep everything the same. 1/3 pi 16 times 10, so that would be 160 minus 1/3 pi 4 times 5, so that would be pi 20. So the answer is, the stump is going to be 1/3 pi 140, or the way we've been writing it, 140 over 3 pi. When I divide that, which you'd probably be asked to do on the test, you'll get, I took the liberty of doing that, over here, you're going to get 46 2/3 pi. And if you choose to turn that into cubic inches or cubic units, you're most welcome to do that. You just multiply this number. You'd round to 100 here and multiply it by the pi button, and you'd come up with your answer. So let's erase this now. You've had a chance to look at it. You can replay the video anyway if you need to, and we'll erase this part here in particular. And now we have to answer the second question. What is the ratio of the small to the large? And I'll write it that way. Okay, and I can flip it if I want. The small cone to the large cone. That's explained to you many times that it really doesn't matter that much to the large cone. But come on, guys, the work's been done for me already, right? I had to calculate the small guy, which was 1/3 pi 20 over here. Okay, no need to even change the numbers. That's the small guy. I'm just writing a little arrow there. And there's the large guy, 1/3 pi 160. Goodbye, 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 goodbye. And so goodbye with the 0. So I have a 2:16 ratio, which of course is 1:8. Now you can look at it any way you want. The ratio itself, though, is 8:1. In other words, it's not 2:1 as you'd imagine. When you're dealing with volumes, you're cubing everything. So the 2:1 would be like 2:3:1. And we'll talk a little bit about that as we go on. And you're able to see that, yes, barely. And so that would be the answer to the other one. So there's the answer to the first one. And either way, as long as you made it clear to the teacher which way you were going with the ratio, there's the answer to the second one. Okay,